So let's quickly fix this problem by simply adding a constructor to the customer, which will be able to accept integer phone number and our string that presents the address. So it should be really like this, just customer, right? So customer, this is the constructor, so it will take two parameters to accept the initialization, and basically these two parameters, right, like this. And we'll just use initialization list to say phone constructed from the phone provided, and address constructed from the address. Okay, very good. And then the body of the constructor is empty because everything is happening on the initialization list. We also want to be able to add a default constructor, because now once we have specific constructor in place, we will no longer be able to construct the derived object using the default constructor. So we have to, because it's taken away as soon as you add this constructor. So let's add default constructor customer, and we'll use a default constructor here, and we can just use the same initialization list, and we can just set phone to 0, right, and address to unknown, something like that, so that we maintain both default constructor and this constructor. So this should give us a free pass right now to eliminate that error. So let's build, and let's see something, syntax error. Oh, I've doubled my colon. So we just have to build again. All right. So with this, so let's rewind back to the change that we really made, which is quite significant. We declared that the print function now is a virtual function, and this is the keyword in the language that designates print to be a virtual function. So the meaning of virtual function is, let's repeat, look, we have we populated our vector with addresses of 3 objects: company, company2, and person, right? So we took addresses of these 3. There are different types. There are 2 companies and 1 person. And we stored these addresses inside the vector. Right, so the vector contains these addresses. So this is our vector like this. It's an object, and it contains a set of addresses of these objects. And now we'll start using these pointers, because these are pointer elements that are pointer to a customer base like this. We start dereferencing this pointer and saying print. And this time, if this is the type of a company, the print function, which is now declared virtual, and you declare it virtual only once. In all derived classes, this print function continues to be virtual. The first print will be directed to the company. The second print, because it's also a company, once again will go and call this function. And the third one, which is a person, will call the person version, right? And let's verify, right? So we'll verify, make sure that everything is built, and we run this. And so here we have it. It started to work like this. So the first time for the company, when we begin to print, right, we print the customer phone number and the address, and then we print the name. Okay, so clearly we just printed this company because inside the company first we print the base part, so we call the base part of the customer, which prints the first line, and then we printed the second line, which is right here. And then again there was a company, and we printed the second entry in this vector using the pointer to the second company that we have. And of course we also have customer residing at 1 South Street, who is the person. So this is the third entry. So it worked. Okay, so this worked. And now we have example of the polymorphism right here on this line, because the same code, we loop through the same code, and yet we get different behavior, because one time we call this function, the second time we call this function. Now let's just for a second or a few seconds switch back to non-virtual version of print. Okay, so keeping virtual in view, that we already know that this works. And now let's explore, like, what is the magic? What's really happening here? Why is it working one way and then the other way? So without virtual, which is now commented out, let's build one more time and run again. And right here we see that we're back to just calling the print at the base class, which was the case before. So this is okay. And so how do things change when we start using this virtual? To show you, I want to print the size of this, to just physical size in memory, physical size of this customer class in memory. So let's do it. And I'll print size, okay, size, and then print size of customer, right? So we'll be printing the size of the customer object in memory, okay, and then we'll just print, just say size is this, and then comma phone, and so forth. So let's do this. Build again. So for our display, I added displaying the size of the customer in memory, and this is only the size of this object in memory. Run this, okay, and it starts printing that the size of the customer is 48, okay, 48 bytes. 48 bytes, and in memory it takes to store a single customer, and this is only the base. This is regardless to these things. Okay, so we do this. Let's copy and paste and just preserve this output for our node. So I'll just make a multi-line comment and preserve this output so we can compare it. Now I'm adding virtual to this picture, right? So this is exactly what we want. We want this to be virtual because our whole idea about the design that we're trying to put in place is to take advantage of the fact that we use inheritance in our code, right? We inherit from the base class, and we want this polymorphic behavior so that when we attempt to print individual customers, we would like to find a way to delegate calls or dispatch calls to these specially designed print functions for each individual type of object. And yet let's go back and run it again. Okay, so this time the picture has changed to this, right? So now we're printing the second set, which is nice. We're now back to printing what we wanted to print. So we can compare it with the new version of the print, right? Which is this. And notice how size changed. we really didn't change anything in this definition of our customer, of our base class customer, except this keyword. So what has just happened and why its size has changed? Well, first of all, what is the difference between 56 and 48? Right, so right here we see that the difference in sizes, right, difference is 8 bytes. Okay, 8 bytes is 64 bits. Okay, so the difference is 64 bits. And look at the type of my build. I'm building 64-bit type of debug version of this application because I'm running this on a 64-bit platform. Okay, very good. Let's switch to a different configuration. Let's switch to x86, which is 32-bit. And build again. And run again. Okay, so now the customer size actually has dropped to, well, yeah, this is we're gonna have to rerun it 2 times by undoing virtual again. So let's just do this quickly. So this is with virtual keyword. Okay, so let's now remove the virtual, just like we did before. Take it out by just commenting it out temporarily, and rerun again, build, and rerun one more time. Okay, and so the non-virtual size of the customer structure is 32 bytes. Okay, 32 bytes, and the difference, of course, here is difference in sizes of the customer structure in memory. The difference is 4 bytes, right? 4 bytes. 4 bytes, which equals 32-bit. 32-bit difference. 32 bits. And of course, x86 architecture is a 32-bit architecture on Intel platform. So there's obviously a correlation in everything that happens. And then, of course, the question is why we change so much, going from 32-bit to 64-bit with a basic size of 48. And the reason is that implementation of string changes. Okay, integer is pretty much the same, it's 32-bit integer, but the implementation of string becomes larger because it also is using pointers of these different types in computer memory, and the implementation of string on 64-bit platform becomes a larger object. Okay, so this is what contributing to the difference between the 64-bit version of the customer and 32-bit version of the customer. Okay, so it's like this. And yet back again to the virtual difference. Okay, so I'd like to now go back to the virtual keyword and explain to you what virtual keyword really does in computer memory with our objects, and how this magic happens that we start calling really begin to observe the polymorphic behavior of calling different print functions at runtime when we're printing, when we bring the virtual keyword back in our next video.